Okay, we are recording. All right, so let me just get going. Okay, so I'm Godfrey Nolan. I'm just going to talk about writing secure mobile apps for drones. We've done over the last few years, we've done a ton of stuff. Last 10 years on mobile security. I wrote a couple of books about it. I'll talk about that in a second. And while the security on mobile apps has gradually got, like back in the day, we decompile an app and find keys all over the place. Those days are kind of gone now. But because drones are so new and people trying to get stuff to market so quick, it's always good to point out, some resources for what people can do to try and make sure that the stuff that they're doing is not going to be exposing people all over the place. Okay, so I do every month. I want to talk a little bit about the drone news. So there's a couple of huge things that happened or are happening this year, in September in particular. So there was this announcement that China is restricting civilian drone exports because it's something about Ukraine, of course. What that means, I have no idea, but I've heard people say that it could mean that there won't be any more DJI enterprise drones sold in the US or outside of China. Whether that's, and not just DJI, it could be Autel too as well. So, keep an eye on that one, because that could dramatically change the industry, because basically what we do is we build mobile apps for drones. So yeah, that could be fun. And then remote ID is coming into force next month. So the FAA have got their remote ID. And then this is supposed to be beginning September 16th. So the remote ID, for those of you who don't know, is that basically your drone has to be able to broadcast via Bluetooth some information about it, what it is, what kind of drone it is, where's it going, that kind of thing. So that if you download a tool, you can see what the drone is. Also, it's going to be good for UTM. So you'll be, the drones will be able, a bit like, the ADS-B for planes. There was some talk that it was going to be postponed for a while, but it's already been postponed. So I don't know if that's not going to happen. And then the other thing is commercial UAV is next month, and that's in Vegas. So if anybody's out in Vegas in early September, we always go to commercial UAV and then a UVSI. Between the two of them, that's kind of like where we get all our leads and do all the other stuff that we do, trying to stay in this work. If anybody needs an exhibit hall pass, please hit me up, because I've got 100 of them to get rid of. If you're out in Vegas or anywhere near, I think it's well worth going. There's usually about 400 or 500 companies there. It's a great way to see what's going on in the industry. Okay, so I'm going to talk a little bit about some of the things, the way that you can hack a drone, more so than hacking mobile apps. I have a Medium article that I'm just going to give you access to. By the way, usually what I do is when I talk about all this, get all the resources, and at the end, upload the presentation so that if you guys want to play around with it later, there should be lots of stuff for you to, if you're really interested in this area, there should be lots of stuff for you to look at after tonight's meetup. Plus, like I said, I also record this, so I put this up on YouTube over the next few days. So if you want to go over and see what we talked about, or just hit me up, send me an email, godfrey@reese.com. So we're going to talk about how to hack a drone, some of the famous drone hacks that are out there, mobile apps in general. Like, why are we talking about mobile apps? Anything to do with drones? That's kind of because in the early days, the drone manufacturers decided that the users were going to use their own phone or their own tablet to fly the drone as the video screen. So you basically have your remote controller, and then you have your phone that's connected to it. Some of the companies like DJI and the more enterprise drones have gone away from that because they have a smart controller, but it's still 9 times out of 10, it's an Android tablet, which means that all of the stuff you can do about hacking an app on your phone, it applies to running it on the smart controllers. I do have a link as well about some of the smart controller routing that went on, was announced, or somebody announced the other day, local privilege escalation, which means you can take control of one of the DJI smart controllers. Talk about the manufacturer's SDK. So basically what's great for companies like DJI, for Autel, for Parrot, And then for the open source drones, each of them, we have a SDK that we can, that's like a headless app, and then we provide our own GUI on top of that. DJI actually gives you a UI UX SDK as well, so they give you some of the widgets that you want to use. You don't have to spend any time doing widgets. But essentially what you're doing with the manufacturer's SDK is you're creating your own mobile app for a drone for whatever workflow that you want. But with all that power comes some risks. So I'm going to talk about the OWASP top 10 mobile security risks, particularly how they apply to the drone apps. And then we'll talk about cloud, because a lot of what's going on is like all of the apps that in the drone space, they don't exist on the mobile phone itself. They're talking to AWS at the back end or something else, or a REST API. So how do you make sure that your REST API is secure? And then best practices, and then some of the stuff that's out there, some good news and bad news. We'll talk about that too as well. So there's been, one of the things that I always recommend is never store anything that you don't want to lose on the phone itself. However, there may be a way with Google's new chip, if you're using a Pixel 7 on the Titan chip, the Android's security jetpack, which means that there is a pretty good secure mechanism for storing stuff. If you do want to, instead of storing it on the hard drive and shared preferences, you can store it on the chip itself, which is a lot more secure than what we've had in the past. So there are some good stuff going on. But as there's good stuff going on, then there's the tools are catching up. So we use Frida a lot, and Frida is really cool. It's like a JavaScript injection tool, which allows you to basically take over the mobile app. So instead of you have to go through the flow of the login to get to the activity that you want to do, basically you can use Frida to just fire up the activity that you want and bypass the login. So there's lots of other cool stuff that you can do. Okay, bit about me. So these are old now. So back in 2012, I wrote this book, Decompiling Android. I did one before called Decompiling Java. So that's kind of like the black hat version of how to get into mobile apps. And then a couple of years later, I wrote Bulletproof Android, and that's basically the white hat. So the Decompiling Android is the attack, and Bulletproof Android is the protection, what you need to do to protect your app. There wasn't really much going on in the drone mobile space at that time, but the concepts kind of generally apply. So how do we hack a drone? What can we do? Well, we can connect via Wi-Fi. So there was a time when 3DR drones were huge. And it's not just 3DR, there's other ones as well, but 3DR, there were some really magnificent hacks where people could log on to the 3DR. It's a Linux box that's running the 3DR drone, log on to it, telnet into it, and the root password is known. So basically kill the processes and watch the drone gradually just return to home. You can use RF. You can use some kind of a physical thing, like I've seen eagles and all sorts of other stuff. And then you can do some jamming with GPS. So basically what we're doing is we're just looking for the weakest link. So the weakest link could be connecting via Wi-Fi. So using RF, so that one of these hack RF, so it's like $100 to get this, and basically you can start playing around with the RF. You can GNU radio and see what you can do to connect. You can use a cheap NTSC screen, which can sometimes pick up the drone video if you're close enough. Seems to work much better with the open source like Blue UAS drones than it does with the DJI drones, because they use a different protocol, LightSync or OcuSync. But we have had some really expensive drones that we played with that we've been able to connect with NTSC. So then, that means that basically somebody else is seeing what you're seeing and you just have no idea. So hijack the video, and then physical attack. So if that means whether you're going to, oops, go back a bit, please. If you're going to be firing at it, if I've seen things where the Danish army were training eagles to attack drones. All sorts of weird physical attacks that were going on, people throwing beer cans at it, dogs biting it, all that sort of stuff. So there's the physical attack, throwing nets around it. There's lots of countermeasures that are out there at the moment. This one didn't really come across very well. So there's jamming. So what's the one that I have for this? So it's the Department of Defense. So basically what they're doing here is they're just, the drone's flying and there's a gun that basically just jams the signal and knocks it out of the air. And everybody seems very happy with themselves there. Okay. Get back to where we were. But really, what I'm after is how can I use the mobile app? Before we do that, I did want to show you this really cool resource. So how can drones be hacked is the updated list of vulnerable drones and attack tools. So this guy's been doing it since 2016. The last time he's done it is 2021. So, and many of these drones are kind of like, they're kind of the cheap, stuff that you get for kids for Christmas, the kind of throwaway stuff. But there are some significant stuff in here as well. There's the old Parrot AOR drones. We got some Wi-Fi attacks going as well. There are 50, 60 thing here. There is a pretty famous one that's in here, if I can find it. So this is Kevin Finister's DJI hack, where he basically got AWS keys from DJI. So, AWS is storing images, it's storing videos, all the stuff that telemetry information on the back end. And this is from, it's old now, I'm sure. 2015, yeah, so it's pretty old. So this was as part of a bug bounty that DJI were running, and then there was a big fight between this guy, Kevin Finister, and DJI at the time. Full disclosure, I know Kevin quite well. He's quite entertaining, but yeah, this did get out of control for a while. But there's lots other ones in here if you want to have DJI Sparks. If you want to see what people are doing there, they're up to 2021, so they're not up to date, but there's a lot going on. So it's so if you're trying to figure out how this all goes together. And here again, we have the 3DR drone, and I'll talk about that a bit more later. But what I'm interested is I know how to decompile a mobile app. So if I know how to decompile a mobile app, how can I use that to find out information to be able to decrypt whatever data is going on, or to find out what the username and password is, or just to see what's going on. And also, for my white hat, I want to make sure that I'm protecting it so that anything that I'm writing, that the data isn't going anywhere that I don't want it to go. So in this example here, we have this comes from the Delta Airlines. We had a bug bounty that we were trying to start with them. This is from a while ago, but this was kind of the classic thing that was going on. So you'd have people at the time didn't realize that you could decrypt the Android apps, decompile the Android apps and get the original source code back. So in this case, what we're doing is we just search for things like decrypt and key. And we found here, this is the decryption algorithm to decrypt information that they were storing in SQLite, which I believe at the time was the password, the Delta password you're trying to log in. And here they have the actual, key that they were using, and it's AES, so it's basically it's a one-time key, and then there's no PGP or anything going on here. There's no multiple keys, no public and private keys. It's just a one-time key which they're using to decrypt everything. So once you got that and it's in the source code, then basically you can decrypt anything you want. So major lesson learned here, never put a key into your code because somebody's going to get it. A lot of times what you'll find is that if people have a key that they want, they'll either use public-private key algorithms, or they will store the one-time key on a server, which they'll basically take over HTTPS. And when you take it over HTTPS, you just get it to decrypt that one time, and then you don't ever use it again. You flush it out of memory, and then you're good to go. Okay, a little bit more about the famous drone hack. So the one was for logging on to the 3DR solo drones. There was a time that everybody knew what the root password was, which is this here. So basically, you could just log on and then cause complete havoc. There is a really good make, which is building a Wi-Fi disabler with a Raspberry Pi. let's see if I got that. So here it is right here. So basically it just walks you through what you need to do if you want to basically build your own jammer. Sure, the FAA wouldn't really like this, but definitely teaches you a lot about what you can do in order to be able to attack. In this case, I think it's just a Parrot AOR drone. So it's a pretty old drone, pretty basic drone, but the concepts are pretty cool. And then this one didn't come across as well, but this is an Icarus box. So if I go to this, no, that's not going to work for me. I think it's in here. Ooh, a second. So this is the Icarus box. So what this is doing is we're using this little dongle here to attack the drone. Let me turn the thing off. So what's happening is that we have on this side, we have the person who's flying the drone, and then we have this little module that's sitting in the middle, which basically takes it over. You just hit the button, and it's basically exploiting the DSMX protocol to be able to take control of it, and then takes control of the drone, and then the other remote controller now has control of the drone. Okay. Okay, but what I want to talk about is kind of the last category. So it's namely the mobile apps. So manufacturers through their SDKs provide a whole ecosystems are developed to leverage. When I did this talk, I did this at one of the Interdrone, like, I don't know, 4 or 5 years ago. There really wasn't much going on in the drone space. When it came to mobile apps, there was Litchi, there was Precision Flight, and there was something else. But, you know, this is, for us, it's huge now. So and they're, you know, feel free to play in the same swimming pool. So we have, what have I got here? So we've got Litchi there's Solex, which is another way of using 3D or Solo if you still got any 3D or Solos. There's Precision Flight and Sky Drones. But there's also Mapware, which is kind of a Pix4D capture clone, which is the same one as this here. There's Aloft, there's Measure, there's Loveland. So Aloft is it's an app for flying drones, but it's also for Aloft Air Control, but it's also for getting Lance, so getting authorization through Lance. Measure is an app that is owned by Ag Eagle now, so that's another one. They have an iOS and an Android, so there's not many. There's kind of iOSs are going out of favor. Pix4D capture, so that's capturing all the stuff that you want to capture for all these different images. Loveland Innovations, that's for residential roofs. So basically what you do is you fly the app over the roof. It uses AI, takes all the images, uses AI, tells you how much it's going to cost you to get whatever tiles you want on your roof for your new roof. And this cool little thing here is QGC, which is Q Ground Control. That's what a lot of people use in open source drones. So it's kind of a different beast here. It's not really an SDK. It's an app that you can customize to do whatever you want. But you're not writing Android, you're not writing Kotlin, or you're not writing Swift. You're writing QML files, which are kind of JavaScript files for customizing it. If anybody wants to find out more about that, go have a look at some of the previous meetups that we've had on YouTube. And there's a ton of information out there for how to customize the QGC stuff, Q Ground Control. Okay, so how does the mobile security allow us to track drones? So we can do that because most drones are on the user's Android device or a smart controller that's running some version of Android. And here's the thing I wanted to show you. So this is really recent, August 5th. So this is on the old DJI or M500 controller. So somebody's figured out how to route this. So even though a lot of the DJI drones and some of the Autel drones and some of the Parrot drones are using their own controllers, by and large, not by and large, almost always these are some Android device running anything from Android 7 and above. And if it's Android, then it's susceptible to being rooted. And if it's susceptible to be rooted, then you can basically take control over whatever apps are on there. So you want to make sure that your app is protected as much. The DJI's new SDK, the V5, which came out about a year ago, well, more now, probably about 2 years, no longer supports iOS. So there's a big push towards Android, and Mavlink has very much been a Windows or Android platform rather than an iOS platform. So that's kind of out there too as well on the Android side. So a lot of what's going on is basically how do I protect my Android app as opposed to how do I protect my iOS app. So we're all talking about APKs rather than IPAs. So why do we have this problem? So the way that when you write your Java file in Android Studio, that Java file gets compiled to a bunch of class files, and then those class files, when they go onto an APK, they all get compiled together in a classes.dex file using one of the tools in your Android Studio, which is called DX, which basically zips all these class files together and puts them in the format that the phone can understand. And then there's this tool called JADX, which you can get on GitHub, publicly available. It's just a download the release. You got a little GUI. I'll show you what the GUI looks like. And that means that you can get back to the Java file. So really straightforward. You know, it's this is script kiddies. This is not something that requires a lot of intelligence. I'm just showing an example from the United Airlines app, but just, you know, imagine this is a drone app, like one of the Litchi apps or something else. So basically the commands that you do is you try to find where the app is. So you do an ADB shell, and you can do this from your Windows box, your Linux box, to say, tell me where this APK is, and it'll tell you where where it is on the phone, so, or tablet, so /data/app. So it's, you know, it's a Unix box. It's underneath everything. So if you got any Unix skills, you can pull stuff up. So with ADB, you can pull off the APK. So you're doing ADB pull to pull it off. So it's called, in this case, it's called base.apk. They're probably called something else now because they kind of change all the time because we're doing AABs now instead of APKs in Android. But it's basically the same, just a slightly different format. And then if you do JADX GUI against the base APK, then it pulls up the code, which kind of looks like this. So that's basically what it looks like. So you get, if you don't protect the code using obfuscation, you basically can see everything that's going on for whatever code that you wrote. Okay, so that's the static analysis, but there's also a dynamic analysis. So as the person's using the phone, they're doing things like stuff's being stored to shared preferences, stuff's being stored to the SQLite files, or whatever it is, or whatever you're storing on the phone. Underneath whatever the data app, whatever the name of your APK is, there's going to be a bunch of information that's being stored. So to get that, if you don't deny access to the Android backup in the Android manifest for whatever Android manifest.xml for whatever you've written, then anybody who has access to the phone can do an ADB backup, and they can do an ADB backup for everything on the phone, or they can just do it for a very specific APK. That is stored in a format called backup.ab, which is it's a tar format with a little header. So there's another utility out there called abe.jar, where you can just basically run Java jar and then unpack it, and then that gives you a backup.tar format. So you just untar it using tar -xvf, and then if you can run SQLite onto the database, and you can see what's going on in the SQLite database. A lot of the times, in order to do this, you have to root phones, and rooting phones can be really annoying. But because never ever root your own phone, because there's a chance that you'll brick it. So don't do that. There are websites out there that basically pull down any APK that's on Google Play. So APK Pure is one of those. So if you just want to play around with some APKs and then see what it looks like using JADX, it's a great way to do this now. Once this APK Pure has been around forever. One of the other things that's really important about this is that if you make a mistake and you put the key in your hard-coded in your app, then APK Pure keeps all the previous versions. So don't just replace the key. Don't just put the key onto a third-party server. Change the key. So you have to go through whatever pain that you need to do to make sure that you're not using the same key, because if it's in a previous version of your APK, it's going to be stored in APK Pure. Somebody's going to download it, and somebody's going to find it. So then if you run JADX, the decompiled code kind of looks like this. Very readable. It's got a little less readable lately because most Android apps are now written in Kotlin, so it doesn't really look this tidy anymore, because JADX will decompile it into Java. But for people who are trying to understand what your app's doing, this is a pretty good way of seeing what's going on. Again, I'm using the United app, but it works with any of the apps out there. It won't work with it won't work with like QGC, because QGC doesn't use doesn't use that Java class file DEX. It uses a completely different thing. It uses Qt. So the cross-platform stuff is harder to decompile. And then so I'll just talk about some of the manufacturers' SDKs. So we have DJI. DJI V5 is Android only now. There's still some support for iOS, but it's kind of going away. Parrot is iOS and Android. They gave away a whole bunch of open source code for the iOS side. Autel is iOS and Android too as well. And then Mavlink is basically what you use for the open source drones. So there's a ton of them out there. And so we use Mav SDK all the time. So if we're doing something with a kind of an orange cube, instead of you have the choice of just downloading QGC and getting QGC to control the drone. But a lot of times what will happen is somebody will want to have a mobile app that works with a DJI drone and a Mavlink drone, and they want to have the same user interface. So a lot of times we'll use Mav SDK, so that's great too as well, because then you get all the functionality from the same as what you get with all the other SDKs. In fact, a lot of what Parrot has is built on top of the Mav SDK. And there's a Mav SDK for C++, for Java. I believe there's one for Swift too as well, and one for Python. Also, if you want to learn more about the SDKs, I went through them all probably about a year ago. So go through the old YouTubes. So how does it all fit together? So your mobile app basically sits on top of the SDK. So in this case, it's a DJI SDK, which operates like a headless GUI. And it's up to you to provide the new screens to price whatever the DJI Pilot app or QGC experience that people are used to. And then some of the SDKs even provide you with the UI UX widgets to make your app look a lot like the manufacturer's app. So, you can have whatever workflow that you want for mines, for agriculture, for, counting cattle or whatever it is that you're trying to do. So how do we create mobile apps that are secure for drones? So these are the OWASP top 10 mobile security risks. This is the kind of the older version, but I think it's much easier to explain the key concepts that you're looking for. So I think this is the 2014. I know there's a 2016 or 2017, but this is just, for me, seems to be really a better way of trying to explain what's going on. So, and these 10 risks, and I'm going to talk about this is on the phone. I'm going to talk about the cloud in a second, but this is the stuff that's on the phone. So what it really boils down to is what static and dynamic information you have in the phone. By static, we mean what's in the code. By dynamic, we mean what info is stored when someone uses the app. So that's the SAST and the DAST that people talk about if you hear about audits. And then we're also worried about the backend server. So what's in the cloud, video images, how does it get there? Is it getting there securely? But like I said, these are the old 2014 OWASP risks, but the new ones cover similar ground, so it's very similar. So for us, what we're looking for kind of insecure data storage. So so this is kind of where the data is stored. Is there any unintended data leakage? And then M3 is insecure communication. So what are you doing for SSL? So SSL is kind of broken, so you have to use SSL pinning to make sure that you're basically you're not allowing anybody to put in a fake SSL cert to pretend that there's somebody else to be able to decrypt the traffic that's going across the wire. Essentially, that's what you're doing. So you're basically saying this is my public key, and you put that into the code, and then that SSL pinning means that somebody can't break the SSL. Because SSL is a communication mechanism, you need to take you need to do a little bit of effort to make sure that you're protecting it for people. M5 is insecure cryptography. Showed a little bit of that before, which is are you using symmetric keys, those one-time keys that we're showing? Because if you are, then somebody can find them. And if you are using them, then you shouldn't be storing them in the code, because if you're storing them in the code, then hard coding keys, whatever, that kind of thing, then people are going to be able to see them. You should really be storing them on a either in the Titan chip if you're using the Google Pixel and the new Android Jetpack, or you should really be, what most people will do is put them onto a server, and then you just call the server to get the key to decrypt what you want to do. Or you should use an asymmetric algorithm so that it's not just one key, so that if anybody finds the public key, it's not really a problem, because the private key is going to save you. Now, a lot of time in mobile apps, people complain about this because you can't really run your app in airplane mode anymore. But for drone apps, I guess that is just as important, because a lot of times what's going to happen is you're going to be running it where there's no internet. So we got to find a way around that, to make sure that the keys aren't hard coded for whatever is encrypting whatever it is you're trying to encrypt. But you're also not giving people access to what the data is. And then, one of the things and then M6 is insecure authorization. So a lot of what happens these days, the hacks that are going on, is on the cloud side. So it's like, what are you doing when you're talking to AWS? Like, are you putting your AWS keys in the code? That's just as bad as putting your crypto keys in there. So you want to make sure that you're not storing any of your credentials in your mobile app, because if you are, then definitely somebody's going to find them. And then reverse engineering. You can use basic obfuscation like ProGuard or some of the better tools that are out there, such as DexGuard, I think it's called. It's ProGuard Pro, for want of a better word. But if you don't have any obfuscation, then I can basically see everything that you've used to write the code. Obfuscation is great because it takes a lot of the information out. It's not 100%. It's not a silver bullet. Don't get me wrong. But it'll definitely make it harder for people to understand what's going on in the code, because all of the variables are A1, A2. There's a lot of overloading going on, and the methods are much harder to understand. So it's like somebody wrote really bad code and it's really hard to understand. One of the things that I'm not touching on here is the whole thing that was going on about whether DJI are storing your data or not. This is nothing to do with this. This is about whatever apps that you have that you're writing to make sure that whatever you're writing is secure. I do know that DJI use this tool called SecNeo, which is really good obfuscation. So if you can get something as good as that, then I think that's a much more professional solution. So here we have the insecure data storage. So someone who backs up your app on their phone, you can see there's a lot of information here. So what do we have? We have DJI Analytics.db. We've got FlySafe Areas DB. So there's all this stuff that's going on. What XML files, ISE, preferences file.xml. So I'm always SDK config. I'm always looking for anything that would give me a hint to see what would be useful to kind of poke at to open that door to get more information. So be careful what you store, what you put on your phone, because like I said, people can just use ADB backup, and then if you haven't protected it correctly, they may be able to find stuff here. This is from the Skydrones app, which was done quite a while ago, so I'm sure they fixed it by now. So don't put anything sensitive. And if you do, the fix is to, in your Android manifest say backup equals false. A lot of times what will happen is that will, when you create it, it'll give you a warning. Android will give you a warning to say you should be making the backup false. And here we have, so this is a shared preferences file. So in this, we have user IDs, we have a user email, whatever the user last name is it the first mission? So there's a lot of information here that we may be able to use. Again, don't put any passwords in here. Probably don't want to put in the user email. And then again, it's like you're a lot of this is the trade-off about how you're trying to make the experience easy for somebody, because people hate having to log in over and over again. But definitely, if there's any password information or anything, you should be not putting in shared preferences. Okay, so don't store passwords, social security numbers, use multi-factor authentication, client and server side access control. A lot of times what we used to find is we'd find that people would do the client access control to make sure that they have the username and password and not do anything on the server side. So the problem is then is that the server side is assuming that the client has already logged this person in. You can't do that. You got to make sure that you're doing it twice. And then sensitive data should be encrypted, and very sensitive data should be stored on the server, which is from a guy called Zapata. A little bit more now on SSL. Although I do want to say a little bit here, because this has kind of changed a bit since the new Android security jetpack. So the security's got a lot better. There's stuff that Google have been doing forever. They had private folders, but if you had a rooted phone, you could get access to the private folder. They'd key store, which was supposed to be the answer to everything. But it wasn't, because people figured out how to get into the key store pretty quickly. And then the current one, which does seem to be very secure, is using the new Android security jetpack. So Android have, every couple of months they come out with new jetpacks for not using Android layouts. We're going to use Compose. And one of the jetpacks they have is for the security. And that, together with the Titan chip that's on the Google 7 and above, Pixel 7 and above, means that we may be able to look again at storing some of the information on the Google Pixel phone. And obviously that's not going to work with some of the smart controllers, but if you do have the luxury of being able to choose what device you're using, that may be something you want to look at. And insecure communication. So basically what we're doing is we're using things like Charles proxy here to be able to proxy the communication that's going on between the user and whatever the company server is. So it's you're flying your drone with your phone, and then it's going back to the web server. But what we're going to do is we're going to do a man-in-the-middle attack. So we're going to use Charles proxy or any of the other burp suite things that are out there to be able to spoof, to be able to pretend that whatever, this is going across SSL, but you're not protecting it correctly because you're not using SSL pinning. And that means that I can basically say, hey, I'm from the same company, pretending that I have this fake cert, and then I can get access to the data. So what does that look like? So in this case, this is Charles proxy that I'm showing, and this information, which is precision mapper. And again, this is from years ago, so I'm sure this has been long fixed. And this is basically, I'm using the Charles proxy to hack the cert, pretend that I've got my own cert, and and then the SSL is decrypted. So SSL basically works using certificates. So we have a public and a private certificate. Certificates are created by the CAs, which are the certificate authorities. And some years ago, hackers stole the root certificate from a CA, and now anybody can pretend to be anybody else. So this means that kind of SSL is broken unless you take steps to fix your HTTPS request and responses. Now, the worst thing that people can do is a lot of times, let's go back a bit. I don't have the code here. So a lot of times what would happen is people would basically say, check to see if this is the correct cert. Check to see if this is giving the correct response. And then if it doesn't work, just send it anyway. So you got to make sure that you're assuming that this is always broken, rather than doing the opposite, which is, I can't get this to work, so I'm just going to send the data anyway. And SSL pinning is the way to do that. So you're basically putting in your public cert there so that it's never going to be able to fake the public cert with a fake certificate authority. So you're always going to go to the right one. Insecure cryptography. This is the one that we showed from the old Delta app. That's nothing to do with drones, but I have found several examples in the drone space where people have hard-coded the raw keys into the decryption algorithms. So use asymmetric, which is the public and private keys, or alternatively leave the encryption key on the server. And now we have insecure authorization. So finding where the data goes is usually just the first part of the hack. We can then look at the code, see if there's any insecure data storage again to gain access to the backend server. In this case, we're using the shared preferences data and the source code to get videos and images from where they're stored on Amazon. And then using a brute force attack, you can guess the IDs. A lot of times people will use, they won't use GUIDs, they'll just use IDs, and they're just sequential IDs. So if you can get one ID, you can basically brute force it. If you use a tool like Burp Suite, it'll just do the brute force for you. So just always make sure that you're not giving people any information, and any of the stuff that you're storing is you're telling people this is the S3 bucket. We've got so much information from S3 buckets, it's embarrassing. So a lot, and people will see a ton of video, they'll see images, they'll see data that's coming from, first responders who never have been shown to anybody. So you always got to make sure that whatever your keys are, that they're not, again, hard coded in this, so it doesn't allow me to gain access into your S3 bucket or whatever you're using. Does not necessarily have to be S3. And then can we do something about this where I can see all the stuff that's going on? I can start to piece together how this application is put together. I can start to look for things like utils, and within utils, I'm going to look to see if there's any crypto stuff in there, and what is it that I can find just using the standard thing. So JADX gets you back to where you started. So this is what it looks like if it's obfuscated. So this is the Litchi app. So there's just, here we just got the different packages called A, B, C, D. And then within here we have lots of different information. Now there are things out there that will reverse the obfuscation. So you can get like hacker tools that will, they won't get you back the original data, but they'll make stuff a lot more readable. So everything's not A, B, C, D again. And the reason that this happens is because all of these applications are running on what is known as virtual machines. So when you're running on iOS, it's completely different. It's down to the bare metal. But if you're running on a Android phone or on a Windows box, which uses the common language runtime, or on Java, it's a Java JVM. The VM gives it away. The virtual machine gives it away because the data and the instructions are right there together, which means that they can run on different boxes. So you can run on one Android phone, it also runs on an Android phone. All the other Android phone has to do is it has to follow the Dalvik virtual machine specification. But because of that, there's a lot more information that each of these phones need to be able to run. iOS doesn't care about that because Apple owns all the phones. So basically they run on the bare metal, and it's a lot harder to find out what's going on. Okay, so let's talk about the top 10 cloud native security risks. So we have insecure cloud container or orchestration configuration. So that's basically public open cloud storage buckets. So S3, and then there's improper permissions set in the cloud storage buckets. There's the container runs at root, runs as a root. The whatever insecure infrastructure as code configuration is there. So somebody's basically doing the latest and greatest, but they're not thinking about it from a security perspective. And then there's tons of information that they're giving away, which means you can start going after some of the data. Okay, can we use injection flaws? Can we use things like SQL injection? Can we use NoSQL injection if it's using a NoSQL database? Are there any OS commands that we can put in there? Any event data injection that we can do to maybe cause some buffer overflows, or just cause us to be able to break out of the box? Improper authentication of authorization, so unauthenticated API access. So a lot of times you can kind of get into, if the APIs are not secured. So if I can find out what a REST API is, or what the REST API is, /add, so, or /edit. So can I put /admin/edit and get the data for much more information? Are you using GUIDs? Are you using random IDs? Are you just using sequential IDs? So does it allow me to gain permissions where I shouldn't get these permissions? Okay. Are we getting unauthorized or overly permissive orchestrator access? So can we get something underneath the Kubernetes to allow me to be able to get into stuff that I shouldn't be able to do? These systems are starting to get very complex. Because of the complexity, the chances of you being able to get in past some of that complexity because somebody's forgot to do something are higher. AWS is amazing, but the AWS security model is a beast. And if you don't understand how to do that properly, then you're going to, there is a chance that you'll be not having set the permissions correctly, allow somebody in who shouldn't be in where they're supposed to be there. CI/CD pipeline and software supply chain flaws. Are you putting your stuff in GitHub where everybody can see it? Are you using insecure communication channels? Using a single environment to run CI/CD tasks for projects requiring different levels of security? Number 5 is insecure secret storage. Same again. API keys or passwords stored unencrypted inside containers. Poorly encrypted secrets. Use of obsolete encryption methods. Use of encoding instead of encryption. So that's using hashes instead of actual encryption. Mounting of storage containing sensitive information. If you're going to mount this somewhere, can I get access to it? Network policies. So you always make sure that you make it as hard as possible in your network and give the permissions as people need them, rather than opening the permissions because you're trying to make your life easier. So make sure that your end-to-end communications are encrypted. Network traffic to unknown or potentially malicious domains is not monitored or blocked. So a lot of times what people will do is they'll just brute force you. But if you're not watching to see if somebody's brute forcing you, then all day and all night you're going to have problems, because the things like burp suite just automate all this for you. Using components with known vulnerabilities. So are you patching? Are you making sure that you've got configuration management to make sure that all your stuff is up to date? Or what packages you're using from third parties that you have no idea if there's any vulnerabilities? What are you doing to be able to make sure that they're always up to date? Are there undocumented microservices and APIs? Are there out of date, unmanaged cloud resources that you don't even know are out there that people can find by just scanning it, or using one of the many scanning tools that are out there to be able to say, okay, well, this is what they used to use for their APIs. So basically I can just go and see what data I can find there and then use that to attack the production version. Same again, are you going after a test version? Is that publicly available? Can I attack that too? Inadequate compute resource quota limits. So am I just going to hit as many APIs as I can and nobody's ever going to stop me? That could do all sorts of things, like get just kill the app, kill the server so that nobody else can use the bandwidth. Some kind of a denial of service type thing. And then the last one is ineffective logging and monitoring. So you may have been hacked, you don't even know that you've been hacked. So make sure that you have the right Splunk or whatever Elasticsearch in there to know that you've been that people are attacking you, and take the appropriate actions. Okay, so a couple of routing tools you want to try there. Try them for your phone. So Kingo Android Root is still out there. It's been around for years now. Don't do this on your day-to-day phone. So if you want to try this, make sure that you're doing it on a kind of a burner phone or something that you don't really care if it's broken, if it's bricked, or use the APK Pure instead. And then for the iOS folks, there's Pangu, which is continuing to be out there, which just is amazing to me. That's been out there for years now, and the latest version of Pangu works on iOS 17. It's in beta. So I think iOS is up to 17, but there's it's a lot of the apps still run on iOS 16, and 16 works as well. Okay, talk a little bit quickly about best practices. Don't store any sensitive user info locally. No hard coding API keys. Use SSL pinning, safety net API. So safety net API is basically a way to SSL pinning we talked about. So that's to stop the certs. Safety net API is to check to see if the phone has been rooted. And then the Android Jetpack security is using the new Jetpack security to be able to store the information securely, especially if you're using a Google Pixel 7. Expire your sessions. Like so many times people don't expire the sessions and the tokens just last forever. So I can back up your phone, restore it in my phone, and then just use your token to be able to access whatever it is that you're trying to access. Trust but verify, the old Reagan thing. Yeah, the person's logged in, but I want to make sure that you really are logged in. So have multiple layers of access, especially when don't assume that the client is always going to be have the best interests at heart. You got to make sure that the server is protecting itself too as well. And the people need to log into the client on the server. And turn off obfuscation. ProGuard is something that you just turn on in, wow, I said that. It's just something you turn on in the build.gradle file. ProGuard can be a royal pain, but it's definitely something that I would recommend, because as you can see from the Litchi example I showed you, it's much harder to see what's going on. So good news, bad news. So Google and Apple are definitely starting to help. There's a lot of stuff that Google is doing with the safety net API for all the stuff that's happening with to protect, to see if the phone is rooted. And then the new Titan chip and the security jetpack is definitely a way to look at protecting your phone. Apple are offering huge bounties, which I thought would kind of disincentivize the Pangu type people. So instead of them producing tools for jailbreaking phones, they just go off and take one of these massive bug bounties that Apple offer, like 200 grand. But Pangu's been around for ages now, so I'm not seeing that happen. I also did want to talk about this thing, the Cult of the Dead Cow. So they're releasing at DEF CON this week. They're developing a coding framework that can be used by app developers who are willing to embrace strong encryption and forsake revenue from advertising that is targeted to individuals. So there are frameworks out there that you should look at, like this one that's just been released this week. So these are the hackers that are showing you how to protect your stuff. So I would take a look at that. Bad news are tools are still evolving. So Frida is frightening, absolutely frightening for what it can do. Basically, it's injecting, so bypassing any of the login restrictions that you have, getting to the next page and trying to see if you can get there. So things like JADX, JD GUI, Charles Proxy, they're all getting old now. So there's other stuff that you can do to bypass your tests. Some resources. So we have where to find the SDKs. This is how the drones can be hacked. OWASP top 10s. And then I have a whole bunch of more information on the bulletproof Android that I put up there. So let me see if I can find that. So it's basically just walks you through this from a kind of a more technical perspective and shows you a lot more examples. I think the one I'm looking for is coming up. Yeah, so we identify the problem, show the real problem, and then fix it. So if you want to take a look at that, if you're interested, that'd be cool. Okay, I am going to, thanks for hanging out with me, guys. I'm going to stop recording now. Okay.